the James Webb Telescope has discovered a colossal giant structure that challenges our current understanding of galaxy growth. Until now, researchers assumed that spiral galaxies formed gradually over a long period of time, but the imposing big wheel shows that we were dramatically wrong. But how is this even possible? How could a galaxy have been significantly more massive than our Milky Way today just 2 billion years after the Big Bang? Well, this isn't the only perplexing question currently preoccupying astronomers. Scientists have now found evidence that the mysterious dark energy has been losing strength for some time and that we may even have to say goodbye to Einstein's theory of relativity. Want to know exactly what Webb found and why our cosmological worldview is once again being shaken? Then stay tuned until the end and find out with us. If you like the James Webb Telescope, it makes the impossible possible. After all, thanks to Webb, we now know that there are objects out there whose existence was previously considered impossible. Of course, there are the sensational universe breakers that existed just a few 100 million years after the Big Bang and which, despite this, were already as massive as our Milky Way is today, and that is problematic, to say the least. According to our established models, there simply wasn't enough normal matter at that early stage to form such star-rich galaxies. So far, so puzzling. But now, Webb has uncovered something that turns even this enormous mystery into a mere footnote. Because here's the kicker, although the so-called Big Wheel existed only 2 billion years after the birth of the cosmos, it was already as large as our home galaxy is today and 5 times more massive. Against this backdrop, it is only natural that this confusing structure is once again putting our understanding of cosmic evolution to the test. And we have chance to thank for that, by the way. The researchers, led by Viking Wang from the University of Malambikoka, weren't actually looking for impossible giant wheels. They were using Webb to take a closer look at a distant quasar and its active, extremely massive black hole. However, analysis of the image, which also showed the region around the active galactic core, revealed an unexpected detail in the left corner of the image, an unusually large spiral galaxy with striking spiral arms. Determining the redshift revealed that the light from the galaxy took around 11.8 billion years to reach our eyes on Earth. In other words, the structure already existed when the universe was just 15% of its current age. Named the Big Wheel and described, experts were also able to determine the galaxy's rotational behavior and found that it rotates at an astonishing speed. More precisely, the rotational speed increases with distance from the center, reaching a maximum speed of several hundred km/s. Furthermore, the rotational speed also corresponds to the Tully-Fisher relation, which describes a relationship between the rotational speed of spiral galaxies and their luminosity, thus allowing conclusions to be drawn about their distance. In other words, the Big Wheel is not only one of the most massive star clusters ever detected in the early universe, but its shape and characteristics also resemble the largest and most mature spiral galaxies in the cosmos today. How did it form? How could the Big Wheel become so massive so quickly? But how is that even possible? Astronomers generally assume that spiral galaxies form gradually over a long period of time. This happens either through gas flowing into the galaxy from the surrounding space or through mergers with smaller galaxies. And normally, one would assume that rapid galactic mergers would destroy the delicate spiral structures and transform them into more chaotic forms. But the Big Wheel has apparently managed to grow rapidly to an astonishing size without losing its characteristic spiral shape. No less confusing is the fact that, despite its impressive dimensions, the Big Wheel is growing at a similar rate to other galaxies from the same cosmic era. And what makes it even more fascinating is the environment in which the Big Wheel was formed. It's located in an unusually crowded region of space where galaxies are practically stepping on each other's cosmic toes and which is 10 times denser than usual. In fact, it's likely that these cramped neighborhood conditions are what made the impressive growth of the Big Wheel possible in the first place. Scientists believe that the Big Wheel probably underwent mergers that were so gentle that it was able to retain its spiral disk shape. In addition, the gas flowing into the galaxy must have harmonized well with its rotation, allowing the disk to grow quickly without falling out of galactic alignment. These factors therefore provided ideal conditions for the galaxy's development and, incidentally, also gave us an absolutely exceptional find. Because at the end of the day, the discovery of the Big Wheel was incredibly unlikely. Expressed in figures, this means that our models estimate the chances of finding such a structure in a survey at less than 2%. Astronomers probably only managed to make this remarkable discovery because it was hidden in an exceptionally dense region that differs so much from its typical cosmic environment. And yet, the mysterious story of its formation is not the only question surrounding the Big Wheel. Its future fate also gives rise to fascinating speculation. Given its densely populated home, it is possible that further mergers will follow in the future and that these will transform the already impressive structure into a significantly larger galaxy. While the Big Wheel poses a galactic puzzle on a relatively small scale, the following discovery affects our fundamental cosmological worldview. But what actually happened? Well, to understand this, we must first remember that the universe has been expanding at an ever-increasing rate since its inception, and that mysterious dark energy is believed to be the driving force behind this accelerated expansion. According to the Standard Model, which is based on Einstein's theory of relativity, wondrous force has a density that is constant in time and space, meaning that we are dealing with a constant. Well, at least that's what we thought until now. On the one hand, astronomical observations have shown that cosmic expansion appears to be much faster than the Standard Model would predict. And on the other hand, evidence has been uncovered that dark energy is actually far less constant than previously assumed. And now, the Dark Energy Spectroscopic Instrument, DESI for short, has further corroborated this suspicion. Basically, this is an experiment in Arizona that was designed specifically to study the largely unexplored dark energy. Experts have now used DESI to map over 15 million galaxies in quasars, providing us with the largest 3D map of the universe to date. To investigate the characteristics of dark energy, the DESI researchers analyzed not only the redshift of galaxies and quasars but also subtle patterns in the distribution of galaxies in the form of so-called baryonic acoustic oscillations, BAO. BAO reflects density waves in the early universe, which cause galaxies and galaxy clusters to form at fixed distances. Scientists can measure these distances at various intervals and thus draw conclusions about the expansion rate, and consequently the influence of dark energy at different points in time. And indeed, the new mapping now suggests the urgent conclusion that the effects of dark energy are not constant, as previously thought, but have instead weakened over time. In combination with measurements from other mappings, the significance of the discrepancy from the Standard Model lies between 2.4 and 4.2 sigma. And the researchers classify this fact as follows. Sigma, we are gradually reaching the point of no return. We now have several datasets that all point in the same direction. The data suggests a changing dark energy, and with greater reliability than ever before. The fact that we are heading toward the aforementioned point of no return is due to the fact that a value of 5 sigma is officially considered a discovery in physics. But what does that actually mean in concrete terms? Well, quite simply, the DESI result suggests that the cosmological constant in our Standard Model is not actually a constant at all. In the most extreme case, this would mean that our current picture of the universe and Einstein's theory of relativity are not correct in all respects. And DESI spokesperson Will Percival says, it looks more and more like we need to change our Standard Model.